Hi, shall we continue? Okay, let us continue. Let us continue for the second example. The second example for the is you can give a try. You can give a try 2y u y equals to 0. Can I solve this problem? Okay, can I make it a little bit bigger? Okay, I hope that you can see the work clearly. Okay, the first simple question to ask, is it a homogeneous? Okay, of course this is a homogeneous. I cannot spend more time here. Okay, this is a homogeneous by obvious. Therefore, okay, let's say the question given here is something they have given a condition. Okay, they have given a assume they have given a condition. This is, we call it as an initial condition. They have given an initial condition for that. Okay, with that, since we know this is a homogeneous, linear homogeneous, okay, I can use a separation method to solve. Okay, you follow me, then later I'll ask one question again and you will know, okay, why am I asking this, linear homogeneous or not. Okay, let's say then immediately I know I can use separation method here. Okay, x, y, y, then this is number 3. Okay, 3 in 1. Okay, I place that in a number 1, which I'll get here. Okay, I just do some manipulation. Okay, therefore I can put it here lambda. Okay, some of you may say, sir, can I bring it this 3, 2 here? Can, no problem. You can use it anywhere, no problem, as long as this constant is not disturbing the whole equation. Okay, you see the first equation, you need to come up with this where it will end up as xx c1ekx. Okay, solution, the first one. Okay, the second one here also, but again, as I say, you can use it in many ways. Okay, 3 to 2. Okay, am I made a mistakes? Yes, I think I made a mistakes here. It's a negative must exist here. Okay, those are really doing the question, then you know, wherever that I'm making a mistakes, then immediately they can point out to me. Okay, okay, y equals to 0. This will give me what I call C2e negative 3 over 2 ky, and therefore can I call it this 4, this is 5. Okay, then the combination 4, 5. Okay, then can I put it into 3? Yes. Okay, 4, 5 in a 3. Immediately you know this is number 2, you need to bring it down. Therefore, when I use combination of these two, which it will give me u, x, y combined together, c1, c2 combined together, you will get it again another constant. Therefore, you don't worry about the constant. Maybe c1, c2 it become a, for example. Okay, it become a, which is, you can say, e times into the combination, where you will get it as a kx. Okay, because you know it's a times, therefore it's a minus 3 over 2 ky. Okay, I can combine together. Okay, you say no, I don't want. Okay, you can put it in a separate. Okay, no harm, as long as you know the way to do it. Okay, now This one is number 6, okay? Therefore, number 2 in a 6, number 2 in a 6, when I place number 2 in a 6 is a x to the 0, x equals to 0, where is a 4e negative x. If a y is a 0, y is a 0, I get here, right? Therefore, you get what you call it as a AEKX. Okay? Now, can I compare? Yes. Can I compare? Yes. Therefore, A stands for 4, K is a negative 1. Okay, once you have done that, can I identify, since K is known value, now I already solved the whole equation. Okay, therefore U is a XY combination for E 4, then you can combine to get the whole solution here. Okay, negative 1, okay, negative 1 minus, that means it's plus 3 over 2 to the y. I think I missed out something. No, just this is okay, it seems. Okay, this is the answer. Yes, is correct. Okay, here in pre-recording, when I use a video recording, I can't afford to make a lot of corrections or something like that, because we don't have time, and of course the battery is one of the issues, and all is an issue. Therefore, I need to make sure everything is correctly done. Okay, with that, we have solved equation solution number, example number 2. Okay, example number 2. Okay, now I'm going to ask you one more questions and see whether you can solve it that or not. Okay, take it this an example. This example. Okay, I give you this example. Xt e negative t cos x u x 0 0 ut 0 t. Okay, take a 1 minute to solve this problem. Okay, use the separation method to solve this problem. Okay, instead waiting for me, just you take a paper. I hope that you are following me. Okay, don't listen to my video recording. No point you are listening to this. Okay, this is not unlike other videos. We just we cannot listen and just looking at what I'm teaching. Okay, no point. You must take a paper, you must copy. Okay, you copy and copy and copy. Okay, that's why I don't want to upload my notes. Okay, these writing notes, because I want you all to copy. Okay, I want you all to take a notes and just make corrections wherever, or maybe you want to update the notes. It's okay. Okay, try to solve this problem. Can? Okay, started. Okay, okay, I know. Okay, many of you, when I ask you to solve this problem, you see, you will follow the trend. What I mean by follow the trend, you just immediately start with the separation method. Okay, you never ask this question. Okay, is this a linear homogeneous or not? Okay, that is a very important question. I already told you. Okay, you must ask this question whether it's a linear homogeneous or not. Okay, first of all, is this a linear? Of course, this is a linear. Okay, this is linear, no doubt about that. But this is homogeneous or not? No. Can you see this? G is already exists. It's non-homogeneous. Okay, it's a non-homogeneous. in this particular case, if it is a non-homogeneous, you cannot use separation method. See, you just stuck. You are just stuck because the simple rule, okay, the simple rule that I taught you, which in order to apply separation method, the separation method must comply linear homogeneous rules. Okay, if it is not a linear homogeneous, you cannot apply separation method. Okay, then how to solve this problem? This is, look at this. Wow, xt and gx. This is what I taught you before, which is, can you recollect back? This is actually direct method. Okay, this is direct method. You can see the combination xt, gxt, direct method. Okay, that's what I want you all to, I want this thing strike in your mind. Okay, don't simply, okay, follow, then quickly conclude. Okay, this is what's supposed to. Okay, when you started with the ux, these things, the separation method, definitely you won't be able to solve this problem. Okay, you need to use, for particularly in this case, you need to use direct method to solve. Okay, shall we start? Okay, therefore let me write here xt equals to xt not applicable. It's not applicable, therefore you cannot use this. It's not applicable. Why? Why? You need to answer because it's a linear non-homogeneous. Okay, that's what I want you all to just remember. Okay, shall we start doing this problem? Can. Okay, come, let us do. Okay, to solve this problem, you need to use option to you. Okay, please observe this. From this observation, you know which one to solve. Whether am I need to start solving the x or t. Okay, the first thing is a t or x. We need to check this. Okay, but remember, you can solve this way also, tx also, because we know in many cases we already, this is a clear root rules, right? Clear root rules always saying this is same, right? Therefore we can solve it if it is a continuous lah. If it is a continuous, definitely is a clear root rule saying you can solve either one of this partial independent variable. Okay, since it's both are equation. Okay, can you see that? Yes. Okay, this is a both are same. I don't know whether I'm writing too small to you to see. Okay, if anything, please any setback, please excuse me. Okay, now in this particular case, you need to smartly work because you need to have ut. Therefore you must solve the x first. Okay, therefore let me start with the txt in negative t cos x dx. Okay, where I'll get a et sine x plus t. Remember, because why? T is a constant. Remember, constant term, therefore this is a constant function. Okay, now we know u t0 t is a 0. How do I know? Okay, how do I know? This is 0. Okay, 0 to the t. In this case, therefore I'll continue with that. Okay, x t, I integrate further, I will get t sine x dt. Okay, you just concentrate on the t. Don't see this is a constant. Don't confuse. Don't confuse yourself. Sometimes you tend to confuse. Okay, in this particular case you will get e negative t sine x. Can I use a theta x? Okay, therefore still there is a option for you to use the initial condition sine x. Okay, if the case is a theta, sorry, it is theta x, where 0 t it go 1. Okay, t is a 1, I get a sign, and this should be negative. Okay, negative. Yeah, that should be negative. Oh, this since is a negative is here, very sorry, there is no negative. Okay, this is a t negative 1, because it's a 0, I get a 1, I get a negative sign. Okay, it's a positive, sorry. Okay, therefore I get a whole answer as sine x e negative t plus 1. Okay, because it's a sine and a plus 1. Done. Okay, now we go for one more example. This example is a very challenging one, and it's one of the past year question. This is one of the past year question. For ux, just now I don't know, 3, this is 4. It's example number 4, right? Okay, I forgot. This is example number 4, if I think. Uy 3u. Okay, first question to answer: is it a homogeneous or not? Linear or not? Okay, all of you got it. This is linear, of course, linear. But question, homogeneous? It's a homogeneous. Okay, this is homogeneous. Therefore, I can use a separation method here. U 0 y e negative 5y. This question is very challenging one. If somebody can able to do this, I really salute you in the first glance. Many of them, they won't be able to do it. Give a try and see. Give a try. Maybe you can accelerate your pace and try and see. Okay, I'll try to do it slowly. Okay, x, y, x, of course. Okay, you can try and see. Are you? Can or not? Okay. Okay, in this particular case, you will get a very odd kind of combinations, which is you never learned this before. Okay, you can see this as a okay, if I substitute here, okay, this substitution will give me like this kind of. How to solve? Okay, this is not an equation anyway. Okay, but how to solve? Just start, right? Okay, how to handle this? Is there any way? Please, I repeat again the same thing. I want you to really understand this process here. Okay, where is that? This logics here. Again, if anything different, you can equate that with the constant. Okay, different functions. Anything different function with a different independent variable, you can equate that to the constant. That means it can be only constant can equate this. Come back to this again. Okay, if this is a combination of one function based on a different variable, independent variable x and y, is there possible for us to do something similar to that? But how to equate here? Huh? Where to put our lambda, where to this thing? But we know this is a constant. But we know this will represent constant as well, right? Okay, it should be a constant, right? Can I use lambda plus alpha become 3? Both are constant? Can't. Okay, this is a very important breakthrough here. Okay, if you can solve and you can think, hey, can I equate this to the lambda and this, but the combination must given me this. Okay, if you don't get it me clearly, okay, if you don't get it me clearly, you see this way. Okay, some of you may say, so we tak nampak lah. Okay, you see, okay, 4 I can bring it down, 4 I can bring it down, please. It's not necessary the 4 must be here. Okay, I can bring it down later. If you don't like it, you can bring it down, no problem. Okay, this is a culprit here, sometimes it disturb you. Okay, you look at this one. I want you to see this. Okay, 3 minus you treat this whole thing constant. Okay, you treat this whole thing is a constant. Can I equate that to the one constant? Okay, can I equate that to the one constant? Can. Okay, this is a one constant, this is another constant, but the problem is the 3 here. Okay, 3, can I put a lambda? Can. Okay, because still same, I'm using the same logics here. Okay, I'm using the same logics of this. Can I put a lambda? Of course. Okay, I can put a equate to that lambda. Okay, no harm to do it that. But anyway, I prefer to use this very fast. Okay, here I get a 4x lambda x. Therefore, I get a x equals to C1e lambda 4x. And what about y? When I solve the y, I get a C2e lambda alpha to the y. Okay, look at this one. Look at this solution. This one is a 2 solution. Here u0y, I will teach you all this technique. This is a very important technique, son. We can write this as a x0, x combination, and y as a something where you get a 5y. Okay, that means here the x0 means I can test this with the x0 what I'll get. Okay, look at this, what I'm doing here. Okay, in this particular case, when I combine these two together, okay, combine these two together, I will get the equation. Since it's a 0, you just substitute here and see x is a 0, what I'll get. Okay, x is equals to 0, I get a, right, the whole thing combined. Okay, x equals to 0, the whole thing disappear, and y, only y will represent. Therefore I combine together, I get a one equation on this. Better I combine anyway. The combination of these two, C1 C2 may give me a or b or whatever, no problem. Okay, but I just combine lah. I'll show you the combination of this. The combination of this will give me e equals to 5. This combination is sometime you won't be able to see that. I may call it here e alpha y, where I get e5y. Okay, now I can compare. Now I can compare where I get here alpha equals to -5, okay, then a equals to 1, okay, a equals to 1, okay. Since assume I already combine these two, make it a, imagine C1 C2 times I get a combination of this 0 is automatically this one will disappear, okay, this one will disappear, okay, therefore I will have only this, I get this, okay. With that, now I know alpha is a 0.5. Can I put it here? What is lambda? Can, right? Okay. If this is -5 equals to 3, okay, is a lambda is a 8. Okay, I've done. I done the equation. Therefore, I don't have the space. I just make sure that I use this little bit mess. If you find it mess, please tell me, okay. Then we know how to get it this ready. Now based on the is it correct, Vida? Lambda is yes lambda is that 3 8 8. The combination will be like this, okay. Therefore the equation for this is u x y is a remember combination of this, combination of these two, okay, I get a e, okay, lambda 4x e alpha y, okay. Okay, then your task is just to place the value here, okay. Lambda is a 8, therefore I get a 2x minus 5y. Excuse me. Okay, this is the solution. Excuse me. Can you see that? Okay. Can you follow? Okay. Can you manage to copy? It's not to copying. Actually, you are solving. Okay. When you solve the problem, you should be able to handle the problem. Okay. Done. Okay. With this, we are going into one more very important equation. I have 34 minutes to stop the class because this can work exactly according to, okay, my battery going to go on. Again, I got one more example to go through with you. It's a very important example. After that, I need to substitute with another battery. Oh, very fast. Okay, K to U x2. Okay, this is a one more example. Okay, is this homogeneous? Yes. Okay, very obvious. This is a homogeneous, linear homogeneous. Therefore, I can use what I call separation method. Let u xt is x t. Okay, this become a second. Therefore, 2 in 1. See, you must follow the order. It's very important. You must follow the order. Okay, you will get t, k, kt. I will go a little bit faster. Okay, x and it equal to lambda. Okay, since we already learned before, the lambda I represent with the p2. Remember? Okay, but okay, leave it now. Okay, from 3, okay, t from 3, I just can solve the things. Okay, t k lambda t equals to t, and therefore I get a c e k lambda t. Okay, Now I call it this number 4, and we know for the second one, if lambda equals to p2 greater than 0, I will have that for the x, okay, because we already solved that, right, for the x2 before. That's why I want you all to practice this. You will get a E px, B E not px. Okay, this could be number 5. Else if lambda equals to p equals to 0, you will get x equals to ax. Okay, we are using a principle of superposition here. Okay, and else we have lambda equals to p2 negative, very important, negative less than 0. This is very important. I don't know whether, okay, the negative L2, because then only you can you able to do it that. I don't know for the previous example I put that as a negative or not. Okay, maybe let me check. Yes, okay, else negative p. Okay, this is correct. Okay, I have done then, because okay, with that, if it is, then the x become Euler formula. Based on the Euler formula, we get this px. Okay, this is number 7. Okay, which combination is a solution? All can be a combination. All this combination can be a solution. Therefore, you see, therefore if I combine number 5 and number 4 in number 2, therefore I get a 1 solution. See how many solution I getting? I'm getting E, K, P2, T, okay, D, E, Px, F, E negative Vx. Okay, 8, number 8, or 6 in 4, not in, and 6 and 4 in 2. For the combination, this is the combination for what? Lambda equals to p2 greater than 0. Huh? This is for lambda equals to p2 equals to 0, where you get a x t equals to cx plus d. Why? Why? E k t become 0. Remember? Okay, this one t is a 0 because sorry, the lambda is a 0. Lambda is a 0, therefore the whole thing become 1. See, you get only this. That's why you getting back the same thing again. Okay, therefore I call it, this is number 9 again. Please follow this example, very important formula, because I won't be able to repeat again this few times only. You just attempt this question and you should be able to do it, the advanced questions also later. Okay, okay, my battery going to finish, then we're going to take another break. Okay, 4 in the 2 again, therefore you get again xt e k p2 t, okay, d cos px df sin px. Okay, px. Okay, this is number 10. Okay. Okay, I think this example will conclude to we managed to do up to few already given a comprehensive examples before we move into the application. Okay, that means we have done several examples Okay, remember these three are solutions, are solutions for the equation called this. Okay, therefore later we're going to analyze step by step which one is applicable for the application that we are looking at. We're going to concentrate in the what you call heat equation. We're going to solve the heat equation and see whether heat equation for the heat equation which solution can be suitable and acceptable. Okay, with that, okay, take a break again.